when you hook up a higher resistance bulb to a battery, it doesn't get as bright as the lower resistance bulb because less current goes through it. But we see something surprising when we put this thing into this series circuit. I'll come over here, swap out this bulb. With the high resistance bulb, it actually seems relatively bright in this circumstance. The low resistance bulb over here, it's so dim you can't even really see it at all. Now I do know that there's current going through this because if there wasn't, I would have an incomplete circuit and it wouldn't be flowing at all. But what gives? This is really odd and it's counterintuitive. It's not what we would expect based on what we've seen so far. So in short, we got a lot to explain. We got a lot to account for. That's what we're going to try to do. Okay, here's my diagram of my series circuit, kind of classic diagram here. And it's got kind of the fundamental pieces. Here's my 2 light bulbs in series with one another. And here is my 3 total volts of electricity because I got 2 batteries hooked up together. So we need to do some explaining here. First of all, why do these things get so dim when you hook them up in series? And what the heck is going on when you have the higher resistance bulb and the lower resistance bulb hooked together? Let's start with the more simple case of having both bulbs be the same light bulb. And in the past, we've said that those, kind of globe light bulbs have a resistance of about 3 ohms. So remember one important thing. We have said before that amount of brightness in a light bulb is related to the amount of current going through that light bulb. So looking at our series circuit, the first thing that we could probably say is going on here is that because my light bulbs are relatively dim in series, there must be less current going through them. Why is that? Well, as a point of comparison, let's remember what's going on for a single bulb case. Here's my diagram for a single light bulb, 3 ohms, hooked up to the same batteries as before. How much current is going through here? Well, if it gets 3 volts of current, and it has 3 ohms of resistance, I guess that would be 1 amp. That gives us that pretty bright light bulb that I started with my video with today. Up here, we know that the amount of current going through these bulbs must be less. Here's another thing, though, that's really important to remember. Okay, let's look at this point. This point is so important to remember. Do not forget this. And it makes perfect sense why it's the case. Think about what's going on in this series circuit. You've got electricity that's going through this wire. It goes through this light bulb, it goes through this light bulb, and then it returns back and completes the circuit. There's only one flow of electricity here. Any electricity that flows into this light bulb is going to pass through this light bulb as well and move on its way. The electric current doesn't disappear as it goes through. It's like water flowing through a pipe. And the water's got to go somewhere. It doesn't just vanish midway through. So what this means for us in practical terms is that however much current goes through this light bulb, it's the same amount that goes through this light bulb. However much current that is, it must be less than 1 amp. It's got to be. Okay, how do we figure out how much? Well, in my series circuit, the way to look at what's going on is that I've got 3 volts powering 2 light bulbs. I've got to shove that current through this light bulb, then this light bulb. This one resists the current. This one resists the current. I guess together they resist the current more. Aha. Key point number 2. In series, add your resistances together. So let's run a calculation at this point. How much current is going through that circuit? Current is equal to however much volts I've got divided by however much resistance I've got. In this case, what's my resistance? It's 6 ohms. That means there's only 1/2 of an amp going through that circuit. And that is why those light bulbs got dimmer. They have less current going through them. Neat. I want to illustrate here just how valuable my mathematical quantitative relationship has been here. We've just been using this very basic relationship, I equals V divided by R. But the mathematics here are not here just to like mess with you and torture us. It's here to make sense of some things. If we can calculate some things, we can sort of play out what's going on. We can think through things much more clearly. It's why we oftentimes layer mathematics onto these sorts of physical situations. It makes it so much easier to think through. If we had to just sort of wave our hands here and think about this only in qualitative terms without numbers, it would just be a lot harder to talk about, be a lot harder to think about. The numbers here are not terribly complex. They tell us a lot. Before we move on from this, I actually want to illustrate one last point that is subtle. You might not notice it, but it's actually quite important for our series circuit. I want you to think about just one of these light bulbs. We said that each of these light bulbs gets 1/2 of an amp. There's another implication of this that's really important. Think about each light bulb in the series. Each bulb is getting 1/2 of an amp. That's got to equal however many volts are being supplied to the light bulb divided by the resistance of that individual light bulb. So wait, for each light bulb, how many volts are they getting? Well, clearly it cannot be the full 3 volts. In order for this equation to work, that's got to be 1 1/2 volts. So here's the conclusion. Each of the bulbs in my series only gets 1 1/2 volts. They actually have to share the voltage. Folks, this is why they don't get as much current. Because when you hook stuff up in series, they don't end up getting the full volts of however much your batteries are giving to the whole circuit. They have to share whatever those batteries have got. So they're going to share those 3 volts. In this case, they share them equally. Each of them gets 1 1/2 volts. This is going to become central for us as we look at the next puzzle. Let's go and take a look at the second situation then that needed an explanation. And that is what happens when I hook up in series a bulb with relatively low resistance and one with higher resistance. Let's say that this thing is 9 ohms instead of 3 ohms, triple the resistance of the other one. What happens here? We saw that this light bulb gets, real bright. I'll draw some of the brightness arrows. And this other one basically doesn't light up at all. And what we're questioning here is why that happens. And in fact, we now have all the tools we need in order to explain that. We have the key properties of this. The first thing that we note and the first thing we can do is say, how much total current is going through this circuit? The total current here is going to be volts, 3, divided by total resistance. In this case, that's 12. So the first thing we observe is that there's only 1/4 of an amp going through this circuit. That's not very many amps. But I actually want to look at, because we're talking about each of these bulbs individually, let's think about what's going on here at an individual bulb level. We've said before that these bulbs are going to share the volts coming from these batteries. And just by intuition, given that this one is brighter, I'm going to go out on a limb here and say they're not sharing those volts equally. I'm betting you this one is getting more of them. And let's see why that is. Here's my 3 ohm light bulb. The current going through it is 1/4 of an amp. I'd like to know the volts. I know its resistance is 3. So how many volts does it get? Well, V has to equal 3/4. So that's all the volts that this one gets. Less than 1. And less than 1 volt to one of these light bulbs doesn't give you very much. Doesn't really even make it seem like it's bright at all. What about the 9 ohm light bulb? Again, it gets the same current, 1/4 of an amp. But now that's got to be equal V over 9. Looks like my volts have got to be 9/4. A little more than 2 volts. So this thing is actually getting 3 times the voltage of this thing. They share the volts, but not equally. Do note those two had better sum up to 3 volts. If they didn't, we'd have a problem. Remember, this is a sharing situation, but the key point here, these bulbs are going to share the volts, but they don't share them equally. The thing that has higher resistance, in fact, is going to end up with more volts than the thing with lower resistance, which accounts for why this thing ends up being brighter than this thing.